Good evening. I'd like to call to order the Bellbrook City work session for Monday, July 26, 2021. Pam, if you could call the roll.
Mr. Hope.
Here.
Mr. Havens.
Here.
Dr. Van Veldhuizen.
Here.
Mr. Greenwood.
Here.
Mayor Schwaller.
Here. We have a motion to excuse Councilwoman Middlestetter for tonight.
Move.
Second.
In a second.
Second.
Mr. Havens, got it?
A motion was made by Mr. Greenwood to excuse Mrs. Middlestetter from tonight's work session. This was seconded by Mr. Havens. Mr. Greenwood.
Yes.
Mr. Havens.
Yes.
Mr. Hope.
Yes.
Dr. Van Veldhuizen.
Yes.
Mayor Schwaller.
Yes. Tonight, the work session is to discuss the results of the Little Sugar Creek borings. Melissa?
Okay, so as you all will remember, we started this process back earlier this year. It was in March that we had contracted to have these borings done, and so Terracon was the company that did the borings and produced the geotechnical engineering report, which was provided in council's packet for this evening's review. And the borings were completed, and the report was also completed in the middle of May. And so it was started in draft form. It went to the service director and myself, and then it was a final copy was released. And so since this is technical information and findings, I asked that Russ Gatorman, who is the one that put together the report, show up for the work session and go through the report and hit the high points, and then allow for council to ask any questions of him. So since he's the expert on that and would be the best suited for that, I thought that that would be a good idea. So Russ, if you want to go ahead, he's got a presentation prepared for you guys, and he's going to go through that.
Like Melissa said, I'm Russ Gatorman. I'm a geotechnical engineer with Terracon. We're down in Cincinnati, Ohio. So this presentation is just, like she said, to go over the high points of the report that I issued, and then give everybody a chance to ask some questions. All right, so how do I go to the next one?
The mouse is up there. You should just be able to just click and be good with it.
All right, so this is kind of Terracon's understanding of the project. There was a landslide that occurred on the east side of Little Sugar Creek Road in February 2019 that started to take out some of the guardrail. I understand that that had moved in the past, but at that time it got closer to the road. Also understand that there's some other areas besides that have moved in the past, and that Bellbrook is looking to both stabilize those landslides and possibly add some pedestrian facilities, a sidewalk along that side of the road. And that if that was to move forward, construction, some of this information is from LJB, who I worked with Dan Hoying, and construction would occur in a piecemeal fashion and not necessarily all at once. If you guys got any questions during this, just feel free to stop.
So you looked at number one, trying to solidify the road. Then secondly, if we were to add a sidewalk on the west side of it.
Correct. It was kind of considering both of those things.
So you might remember LJB had made a report that looked at a couple of different options. It's actually posted on our website. That report was, I believe, published in 2020. And so that report was provided, and this is just a further study of some of those findings in that report from LJB.
Okay.
So did you do something different to consider and then not consider the pedestrian pathway? Or did you just consider the pedestrian pathway?
The way the report is laid out, we just considered it.
Nothing different for not considering it.
I mean, there would be a difference. I can get into it later. There could be some differences if the sidewalk wasn't going to be put in place.
Okay, thank you.
So our scope of work was to do some test borings, soil borings in the roadway, take soil samples and take some rock samples. We did a geophysical survey, which I'll get into a little bit more. It'll be easier to understand. And then we were to provide a conceptual discussion regarding the options for the remediation, stabilization, also considering the sidewalk. LJB asked us to discuss how to prioritize which areas to possibly approach first. We provided some preliminary pier wall design information, and then we issued the report like Melissa said. So our field work consisted of 10 test borings in the northbound lane that were performed in the roadway. They were spaced, 200 to 350 feet apart, starting from Franklin Street and then going up to the park. So these are our borings here. Between 6 and 7 is the area of that slide from 2019 where geotechnology did some work in 2019, 2020. So the test borings went 17 to 30 feet deep. They all terminated in bedrock. We did some geophysical surveys, which is where we put some instruments on the ground. We essentially strike the ground. The instruments listen for the sound waves to come back, and then we can kind of map what's going on underground. I'll show an exhibit for that. But we did one survey essentially in the northbound lane along the whole length, which is about 1,900 feet. And then we did 2 supplemental ones. It's hard to see, but there's some smaller lines, and we did those off the road and the shoulder of the road. The purpose of doing those offset ones was to see if there was any difference in the rock between in the road and then off the road to see if the rock was sloping. Where the bedrock is depth-wise is important for pier wall design. So this is, we did 10 of these. This is an example of the boring log. We have one of these for each of the borings. This just essentially tells you what's going on at each test boring location. We got into different materials. First is existing fill, which is material that's been moved by man before. It's been altered by man. It's not native, not natural. So that's associated with original construction of the road. Then we got into natural soils, cohesive soils, which are clays, and then granular soils, which are sand and gravel. And then we got into bedrock. Bedrock is interbedded shale and limestone, pretty much universal around this area. So there's a weathered brown shale zone, which is rock that is essentially weathered in place, and then it gets into what we call gray shale, which is unweathered bedrock. The brown shale is a little bit weaker than the gray shale, but still bedrock. So this is the geophysical survey. This is the line that was done in the northbound road. Maybe a little bit hard to see, but on the bottom axis is distance in feet. On the vertical axis is depth, with 0 being at the ground surface. So these contours, there's different contours here that have a color scale to them. And this is shear wave velocity, essentially how fast waves move through the subsurface. We can kind of use that to tell what kind of material is down there. The purpose of this was to, if we do test borings, which are the logs right here, we just get information at discrete points every, 100 to 350 feet. So the purpose of the geophysical was to kind of gather information in between the test borings to make sure there wasn't a big dip in the rock or something like that. So on this, we have a couple things. Let's see. There's this gray line is the top of what we're approximating the top of weathered bedrock, the brown shale, and the black line is the top of gray shale and limestone bedrock. So 0 starts down at Franklin, and it kind of undulates, along the whole distance. It ranges anywhere from 10 to 25 feet, the depth of bedrock. The area of this, existing slide is right in here, and that's actually one of the areas where bedrock is shallowest, which is a little bit surprising, but so there's areas where bedrock is actually deeper than where the existing slide is, and where it's actually deepest is up here on the north end, kind of the part that's next to the park up there. So this is just a little discussion on why the slopes move. So roads cut into hillsides like this, I mean, it's very common for slips to occur on the downslope side of the road. It could be for a number of reasons. One is weak soils that were put there during road construction. Either they weren't compacted properly or they were just kind of dumped there and they weren't put in place. This is especially true if the roads were built, you know, a while ago. Another reason is if you put the soils at too steep of a slope, it's going to want to fail and kind of flatten out essentially over time. Another possible reason for landslides is as our bedrock in this area weathers, over, you know, long period of time, hundreds, thousands of years, but as it weathers into soil, that soil can be very weak and you'll get essentially a failure surface where the soil and the bedrock kind of interface. And then another reason is water. If the water is often a contributing factor to landslides, so if you get saturation or if water is not shed properly, it can lead to landslides. So these are just some, not all these are particularly applicable to this situation, but these are just some options to, you know, remediate landslides, and some of these can be paired with the sidewalk construction. And these are just things that are common, you know, in the region. The first is just do nothing, essentially. You wait and see what happens. You don't do anything. The slide starts to affect the road, then you approach it then, but otherwise you just kind of leave things how they are. The second option is a short retaining structure. And what I mean by that is just a short, 3 to 5 foot tall retaining wall. You know, the slopes off on that side of the road, so if you were going to build a sidewalk out, you're going to have to put a little bit of fill out there to accommodate that sidewalk. There's not a lot of room on the downslope side, so you might want to build a retaining wall just to facilitate that sidewalk construction. I'll talk a little bit about that next. There's an earthwork solution, which essentially you re-engineer the slope so it's not so prone to slope movement and failures. That's a significant undertaking, and with the geometry the way it is, it's not really a feasible option for this, but I just put it in there just for consideration. Soil nail stabilization, I have a picture that I can show you. They essentially come in from the road and shoot or drill these nails into the slope to kind of hold that slope back, and then they grout the face of it. It's definitely a feasible solution for just if you're going to address landslides, but if you want to build a sidewalk, it may be a little bit more difficult to implement that. And the last is a drilled pier retaining wall, which is the most robust but also the most expensive, but it's probably the most effective solution to both address the landslide and accommodate the sidewalk. So this cross section is, you know, the road's up here. This is a slope down to the creek. This is from LJB's report. This is a drilled pier. Kind of ignore this, but you know, if you were to want to grade this out a little bit to facilitate the sidewalk and put a short retaining structure here, the issue is if you start to get landslides, it's essentially going to undermine that retaining wall and go around it. So yes, a short retaining wall would be effective at facilitating the sidewalk, but it would be prone to landslides, and if the land started moving, it just wouldn't hold up to those landslides. An earthwork solution, you know, the goal of this is to A, rework the existing slope that's potentially slide prone, and then B, to flatten the slope. So a lot of the slopes now are pretty steep, and that's, you know, probably a contributing factor to why there is some movement. So you would either, you know, you would do a combination of reworking this and then, you know, potentially flattening that slope. Now that slope goes right down to the creek, and there's not a lot of room for this to happen. You'd also have to clear that whole slope and get a lot of construction equipment in there, and this is just pretty much a massive undertaking, and I don't think it's very feasible for what you have here.
So you have 3 lines up there, the bottom being the existing, the middle one being what we could do if we weren't worried about the sidewalk. Is that correct?
So the black here, the middle one this is just a cross section for one of the stations. This is the existing.
That's the existing. Okay.
This dotted line is just to show that you may have to dig this out and kind of rework that portion of it
Okay.
to get the slope to not be prone to failures anymore. And then, you may need to extend this out to facilitate the sidewalk and kind of flatten this angle a little bit.
Any idea where the bedrock goes as that hill goes down the hill?
It's pretty flat, so it doesn't slope as much as the ground surface does. So, I mean, we did our borings in the road, and then we did some of those surveys out here. And then geotechnology did some borings out here, but, you know, the bedrock, it doesn't follow this line. It's more horizontal.
More horizontal. Okay. Do you have that data with your, where you slapped and recorded the sound waves
Yeah.
going that way?
Yeah, so we did the one line, the main line on the road, and then we did those two supplemental smaller lines. Those smaller lines were just to confirm that or find out what the bedrock was doing off of the road.
And was that in the report?
Yes.
Okay. That's line 2 and 3 at the bottom?
Yeah.
Okay.
Did you notice if there was any localized water drainage issues? The reason I ask is the neighborhood that it's to the west was recently built up within the last 10 years or less, 5 or 10 years. And I'm just wondering if any drain runoff from that neighborhood, maybe localized, has exacerbated any slip issues.
I walked it. I didn't notice anything in particular in regards to that. Not to say it's not there, but I didn't notice anything like that.
Would you say that the drainage system on the west side of the road looked to be functioning properly?
I guess I didn't pay too close of attention to it. I think there's a drainage ditch on that side. I mean, what would really tell is if during a heavy rain, if that ditch was conveying the water to an outlet, or if it was, you know, overrunning the road, and the ditch wasn't working. So,
Okay.
yeah.
I've been down through there under heavy rains, and drainage doesn't do anything after a certain amount of water.
It flows on the top of the road, or
Yeah. Then the drainage, it pools up between the road and the hillside
Oh, really?
around the drain boxes, and then it goes over. It's not even close to being adequate. But I'm talking about pretty heavy rain. We get several of them a year.
Right. Yeah, especially this year, it's been pretty.
If you catch a good rain, go look at it. It's there.
Yeah.
Do you have the data like you were showing for line 2 and 3 for all of the borings?
What do you mean?
But data perpendicular to the road rather than just along the road?
We didn't run any perpendicular to the road, so we ran the main one along the road and then the supplemental ones off the road, but they were still going with the road. But we were just seeing what rock was at those 2 points.
Okay, so you didn't
So we didn't actually physically get data perpendicular.
get any perpendicular data?
Because
Okay.
I mean, you have to run a line essentially across the road, and then we need some distance past that too.
Okay.
So no, we didn't run it perpendicular. So sorry if I misled you before.
I'm glad I clarified that, so.
So this is the soil nail stabilization. Like I said, they come in from the top here and essentially anchor this in. Then they usually put a shotcrete face. It's an effective solution, but it works best if they're just working with, you know, the slope that they got. If you wanted to, this is just example pictures. This isn't your road, but you know, if you wanted to add some space here for a sidewalk, then I don't think this would work as well. And this is used not all the time, but often for emergency repair because they can get in and get done and don't have to disturb a lot.
those nails go down to the bedrock, or
Not necessarily. There's specialty contractors that install those, and they kind of have their own engineering that they do. But they usually run an analysis to see how far in they have to go, but they wouldn't necessarily need to go to bedrock. They're usually 15 to 25 feet long, generally.
So that gives the bedrock on most of those borings.
Yeah, and they may want to. It just depends on the situation, but it's not a requirement.
Jumping ahead a little bit, has this road moved since the storm in 2019 when it first started dropping off? Did we tell if we've had a shift?
So we had a, Ryan, do you remember what that, it was an inclometer, or I can't remember what the name of that device that was installed?
Strain gauge.
Inclinometer. So we did have one of those installed, and it's still there, I believe. And so we left it there so that we could take future readings. The readings are, I think, a couple $1,000s a piece. So since we haven't had any issues, we haven't read
So
it
we
again.
don't know if it's moved or not since
No, but we do
2019.
have a device that's in place that we
Okay.
can get a reading off of if we need to. It's just they're really expensive to read from, so we haven't had a need to read it, and so we haven't.
I thought there was something in the reports in March it moved some. In the
Not
report.
this March.
Not this March?
Uh-uh.
Okay.
I think it would be wise of us, if we don't do anything between now and next year, to read the strain gauge in the winter and then read it after the summer. Those 2 points will tell us if it's moving. If we're not reading it, we're not using the getting any information off of it at all.
Do you know if they took an initial reading when
They
they
did.
installed it?
So we have a baseline. Yep.
No, I mean, the other way to tell if it's moved is really just the road. If you have to patch it, or
Yeah.
I mean, if it starts cracking, then I mean, it's
You know
kind of
it's moving.
obvious. Yeah.
So we've not seen much of that, Ryan, as far, okay.
So backing up to that nail solution, are those things, is that my mic? Louis, is that my mic? Okay. Are those nails, or whatever they are steel, galvanized?
They're steel, so it's almost like a piece of rebar, and then they'll grout them in essentially.
And how frequent are they?
Like 5 feet spacing.
Okay.
It's usually, yeah.
Do you have any idea of, like, not cost numbers, but factor of cost? Let's say if we had a piered wall, and then or compared to the nails, is it twice the amount of cost for the piered wall?
They're usually competitive with each other on
Okay.
projects I've seen.
Okay.
in the
So
same
then the
ballpark.
added cost really is if we wanted to do the pedestrian sidewalk.
Yeah.
Any idea of factor?
I mean, as far as just a standard drilled pier wall or the soil nail stabilization, I mean, it's usually between $100,000 to $200,000 per 100 feet along the road.
100K per 100 feet.
That might have gone up recently,
Yeah,
but and there's a lot goes into it, but yeah, 100 to 200K per 100 feet is what I've seen for a basic type of wall.
And our length is how much?
1900.
How much?
1900.
1900. I apologize, folks, I had 6:30 on my calendar.
So just referring back to the report that LJB did, they looked at the piered wall and they made a recommendation that that would probably be the best situation, and they did cost it out based off of the only boring that we had where the slip was, where the inclinometer is. So they made an estimate based on that, which is why we had them come in to do the borings to figure out exactly how deep the bedrock is in different places. So that really did two different things for us. What it did was it helped us to understand how deep the bedrock is so that we could get a better estimate based on a solution that we're looking at. And then we would also have that data in case we do have another major slip. Then we know exactly where the bedrock is in that area to be able to fix it and come up with a faster solution so that we're not in a bad situation and trying to scramble to figure out how to fix something that's emergent at that point.
I need to go back, but I can't figure it out at least. I advanced to the end and I don't know, it keeps going forward.
I can get the keyboard and hit escape and then let you drive again.
If maybe you just hit the left arrow key, it might go back. Go forward one, yeah, right here, yeah. So this is example details of a drilled pier wall, but essentially it's a drill rig drills them in. They're round caissons. People call them just drilled circular shafts that are filled with concrete, and then they're reinforced with either a reinforcing cage or a I-beam. So this is a cross section. This is just an example, but you have these structural shafts that really carry all the load and do all the work, and they typically go down to bedrock. And this on the right is kind of looking down at it. So you'll have these structural shafts, and then there's two in between we call plug piers. Those are shallower, and these pretty much just hold the soil back and prevent soil from moving through here. That way we can space these out a little bit more, and there's reinforcing only in a couple of them and not all of them.
Do we have these slides?
Yeah. Something
Where
like
at?
I have the PowerPoint, I can send them.
Yeah, I'd like to see these slides, please.
Okay.
Thank you.
So this is just a picture of what a drill pier wall looks like installed. So these, what you can see are the structural shafts, and then there's plug shafts that you can't see in between. In this situation, the slope actually did move down slope after these were installed. So this is doing its job. It's holding the road up, while the downslope side moves.
So, roughly, what is the normal spacing between an actual structural pier?
4 to 8 feet, and
Okay.
6 to 7 is probably the most common.
And then is that attached to the bedrock, or is it just drilled roughly close and then?
Drilled in, so it's drilled into bedrock, and we'll usually specify 5 or 6 or 8 feet into the bedrock.
So if we had that situation there and had the piers installed, and then all of a sudden on the east side the road started slipping away like what that did, we'd have a mess over there. All the dirt be going down the creek and all that kind of.
Right, but hopefully this would hold up the road. I mean, the goal is to hold up the road on the other side.
Right.
And let the downslope side just do what it's gonna do.
So if the downslope side goes away, are we still good?
So that's part of the design, is considering how much of that can go away. So conservatively, we'll just assume that everything down to bedrock goes away.
Okay.
That usually doesn't happen. And then there's some different guidance from ODOT about how much to consider that goes away, but that's part of the actual design. Because, I mean, some of the bedrock was 25 feet deep, and you're not going to lose all 25 feet, probably. So it's just something to consider.
Okay.
Are there any examples of this construction in the local area that we can maybe visit?
I know we have a bunch in Warren County. I don't know about up here. I can get back to you on that.
Okay.
Well, I mean, I'll get back to you. A lot of times this doesn't end up moving very much, so these end up getting overgrown and buried, so you can't even see them, but they're still there working. But I'll see if I can find some that are close. I'm sure there's some around.
So if we had a sidewalk, do you offset where the piers are located to make room for the sidewalk, or is the sidewalk cantilevered over?
And LJB had that in their feasibility, and there was a couple different options. I mean, one was to build essentially a concrete barrier on top of these, and then the sidewalk would be, right here. And then one was for the sidewalk to be a little bit off of this, and then just put a guardrail between essentially this wall and the sidewalk. But they had a couple different options in there, so there's not a set way to do it, I guess.
Okay.
But there's a potential that Only right next to the sidewalk, there could be a 20-foot drop off or a 10-foot drop off.
Potentially, yeah.
Okay.
And I think no matter what, they had some kind of barrier there,
Yeah, they
considering
did.
there was gonna be. And I mean, even if the soil was still there, that slope is really steep in a lot of places anyway, so.
Okay.
Melissa, maybe we could send that report out to everybody in council. so
It's
everybody
on the
has it for-
website, the LJB.
Yeah, access through what?
It's on, current projects. So you would go to the top to departments,
Okay.
and then there would be service, and then there's current projects. Actually, I was in there updating it today, that's why I can say it off
Okay,
the
under
top of my head.
service then, okay.
Yeah, current projects, and it talks about Little Sugar Creek Road and where we're at with it, and it's got this report, and it's also got LJB's report. They're all right
nice.
there.
Okay, good.
So this is some preliminary designs for just different areas based on the depth of the bedrock. I won't go into it too much, but really what controls the design is where bedrock is, where you assume that failure plane is. The deeper it is, the more reinforcing you need and more structure you need to hold it back, essentially. So you can reinforce it with steel beams, which is these W sections right here, or, standard reinforcing cage, which is on the far right. Again, this is just preliminary. Unfortunately, where you did the original study is where bedrock is essentially shallowest, so the estimates that LJB did for that are probably low considering the rest of it, because bedrock is deeper. I don't know if they've run any numbers on this, but the original estimate is probably low.
That's reassuring.
Sorry. Yeah.
Is what it is.
I mean, unfortunately, I mean, there's already landslide issues, and then to add a sidewalk to it, you essentially need more room, and you're kind of putting it on top of already slide prone area, so it's a little difficult. LJB asked me if there's any way to prioritize which areas to potentially attack first if you're not going to do it all at once. I mean, number one is address areas that are currently moving or have previously moved. There's the one area you did the borings on, and then there's two other areas that I saw evidence of that movement has occurred, and one was near our boring B8, and one was near our boring B2. The next area to consider is where that slope comes up. I mean, some areas you have a buffer zone before it starts dropping off, but other areas that slope essentially comes right up to the road. So if that started moving, you don't have any buffer for your road, so that's another area to prioritize. Generally, the steeper the slope, the more prone it is to movement, just very generally. And then I mentioned that existing fill. That's generally more susceptible to movement, just probably because it wasn't placed properly and it's relatively weak. So these are just things to consider if you were to prioritize it. And I think that's all the slides I had.
You identified 3 areas that dropped February 2019, according to your report. There's 3 areas that actually you saw where the road dropped. Where did that soil go? Did the bedrock fail? Did the soil wash away? What happened?
It's a little hard to say because I just saw essentially stuff at the surface, so I don't know. I mean, the top moved and the bottom moves out, and the bottom probably eroded away or just bulged out. There wasn't. I mean, the slides that I saw weren't drastic. They were just slight drops next to the road, but they were still there. So it wasn't. I mean, it wasn't a massive amount of earth.
If you looked at the guardrail, you could see there was quite a bit of movement.
Right at the one area, yeah.
One area.
Yeah.
That was one of the areas you identified.
Right.
Yeah.
Yeah, I didn't walk down below, but I mean, usually they kind of rotate, and at the bottom, the soil either just bulges out, but if the creek's down there, then it could be eroded away. But I didn't walk down there. And I don't know how close the creek is for that, but that's another thing, is if it keeps moving and it keeps eroding away, there's less resistance, and then it just keeps wanting to progress, so it just keeps happening.
Is that part of the fix, is to kind of keep the creek away from, because if you walk down there, creek's right up against it, and it, constant. And it's like a cliff
Right.
going up,
In some areas,
well, the area that slipped real bad.
yeah.
And so, and you're saying that the base is not that good either, right?
Right. I mean, like with the drilled pier wall, the goal is just to address it from the surface, hold everything back, and then not worry about the bottom of it. So that's the kind of the purpose of the drilled pier wall.
That takes care of, you don't have to worry about the bedrock or anything at that point?
Creeks meander and change all the time, so unless you build a wall along the creek,
Right. And
you can't.
and erosion, water's, it's powerful and it's hard to
Yes.
fix and stop. And yeah, you could, put a bunch of riprap and try to put a bunch of erosion control down there, but I don't know that.
That causes problems downstream.
So, sir, on page 9 of your report, 6th line of the paragraph, first paragraph on that page, do you have access to look at that?
I have a
Here, Russ, I got it right here. I'll just give you the whole thing. That's the first part. That's the continuation if you need it.
All right, say that again.
So page 9, first paragraph, under drilled pier wall preliminary designs. 6th line starts with therefore. Can you explain what you're saying there in different words?
Yeah, so we did the test borings in the road, and the bedrock is relatively level, but it's not completely flat. So as you move from the road towards the crest of the slope, there is a dip to the bedrock. What I'm saying is, when I did the analysis for the design, I considered that bedrock was a little bit deeper than it was in the road, just because it is going to slope a little bit.
Okay. Thank you.
So we've now done borings throughout the entire 1,900 feet on a selected basis, so we at least now know the depth of the bedrock at the various points. So in your mind, what is our next step? Just to save up our money so we can put a piering system in, or to do additional analysis or research? Or, we can obviously go and check to see if we've got any movement since 2019, but other than that, just kind of curious where you see the next step going.
I guess it depends how you want to prioritize your money. If you are really just want to save money, then you just kind of wait and see, and if that one area that has moved starts moving more, then you address that 150-ish feet or whatever it is, and then wait and see till the next one.
So you're basically saying we don't need to do any more engineering. We've got most of that stuff done until we decide to start putting in the borings or the piering.
Yeah, I like she said, the goal was just to get borings every several hundred feet, just
Right.
to know where the rock
Right.
is, which I think was a good idea. That area is pretty well covered.
Okay.
Depending on some of the other areas, you may need to fill in a gap depending on where it is, but yeah. So I think you have good information now that you have in your pocket.
By waiting to do something, is there any greater cost that we could see further down the road by putting things off? Or is it pretty much, it's a price tag we're going to either take now, take later, or take in little pieces?
I guess if you did it on, like if it moved more and you took out a whole lane or something, if it was an emergency basis, there might be some extra costs just due to that kind of situation. And then if it did move more and you lose more road, then you have to rework the road and pave a little more, and maybe there's a little more incidental work like that. But as far as the wall goes, not really. Just time and costs go up, but
Right.
Outside of that, no.
Would heavy trucks or heavy traffic have an impact on it?
Theoretically, but practically probably not. I mean, so when we do slope stability analysis on, for roads, we usually put like a traffic load in that analysis. It's like 250 PSF, just like an area load. So based on like a slope stability analysis, that load doesn't usually change the factor of safety too much, so
Okay.
probably not. I mean, if you had, that it's probably mostly residential, right? Traffic on that. I mean, if you had a bunch of semi trucks going over there every day, that might be something, but
School buses are what I'm worried about,
okay.
full of kids.
So there's school buses, and right now there's cement trucks because there's a lot of construction further out.
Yeah, it's
Yeah.
true.
The construction trucks use that a lot.
Okay. It's kind of hard to quantify, but it's not something like, it's not going to make a huge difference.
Thank you.
Is the 25-foot depth of the bedrock, I read this, but I can't bring it back to memory. Is that a lot of the length of it, or is it a lot of it more shallow than that?
Most of it was more shallow than the 25 feet. That was mainly the north end. I would say it's not isolated, but it's not a majority.
Okay.
Majority, I have different ranges in that table, and a majority was in the middle range, not the deeper range, I would say.
Which would make it less expensive for the pier, a little bit.
A little bit, correct.
We had that erosion back in 2019. Didn't we just dump a lot of dirt in there? A lot of fill dirt?
LJB told us we shouldn't do that, add any more weight to it.
Okay.
But that improves the slope, doesn't it?
You're talking about what has moved, you just dump stuff on top of it? Yeah.
We used to just dump stuff on top of it.
Yeah, it's usually not a good idea.
Dumped a lot of stuff on the east side when we had that erosion that time. We had,
Yeah, I thought we dumped it over the side and let it roll on down. Okay, so we didn't like dump it on top of the hill.
No, we would actually level it out with our backhoe,
Okay.
best we can, just to get some sort of, fill the gap, I guess.
Okay.
okay.
And that's a bad idea,
Yeah.
if you just put it on top, it's a bad idea.
but we're not putting it on top, we're
Okay.
pushing it over the side.
Okay.
So is that a good idea or bad idea?
We'll start dumping again. It seemed to work for years, and this happens.
So you say that again, you just push it down the side?
Dump it over the guardrail, and then with our backhoe, we just fling it and try to get the sun grading
Okay.
down as much as we can reach.
And some of it would go down to the creek essentially? Yeah, I don't see that as harmful. If you just dump it on top of what has moved, that's not
Right.
good. But if
Yeah.
it's down the slope, then
That's what I was thinking, okay, thank you. So we weren't really doing bad back then.
Well, it sounds like you were putting it in both places, dumping it on top of what sunk, but then leveling it out.
Yeah, we didn't want to create like where water can't run off. We wanted it to roll off down to the creek like it should.
But
Right.
you're still adding weight to the part that sunk, which is what,
And that's why LJB said no.
yeah.
But what makes it slip in the future is if the slope of the soil is too steep. So by pushing it over the edge, we're making the slope of the soil not so steep.
right. And I don't know if you're adding enough to really make that much of a difference, but if it worked, it worked. It could have been coincidence too, I don't know. Usually slopes, usually landslides, they'll start moving again once you get a lot of rain. Usually it's when it rains a lot.
Okay.
And sometimes it's random too. It's hard to predict.
I understand that there's springs under those roads, and the water went actually under the road and eroded from underneath. Is that not correct?
You guys get any indication of a spring when you drilled?
I don't think we hit any water shallow. Not to say they're not there, but
Well, they're likely there because they're all over Bellbrook.
Yeah. Any other questions of council?
Would it make any sense to cut back up into the hill? Get that road west?
then you potentially create issues at the top of that hill. I don't know what's up there.
Houses.
I mean, you solve one problem and create another probably. Just, yeah.
So basically, the soils around here is not very stable at all. It doesn't sound like by some of the descriptions.
Yeah, it's just a combination of things. They're not necessarily well, some of them are. There's a steep bank, and and there's fill soils that were placed on top of them. So on slopes, they can be unstable.
There's a lot of fill around here.
Yeah.
So it sounds like maybe our next step is to bring back LBJ and have them kind of cost in the new numbers with all this new information.
Can certainly do
Kind of
that.
associate dollars with what we're doing and think about which path we want to take going forward, but there's certainly a lot of things happening. You know, one of the options we looked at before was doing some work with the stream to try to control it and maintain it, and they were gonna tie up logs on the shore and do all kinds of different things to kind of keep the stream from any further erosion. Have you had much experience with that, how that operates, or?
I'm not really a stream guy. I mean, I'm familiar with it, but it's not really my expertise.
So notionally with that approach, they could reroute the stream away from the road to give us more of a landing pad to create a shallower slope to support the road. Does that remotely sound like an appropriate approach?
Potentially. Depends how much you can gain back at the bottom.
I think rather than rerouting, it was just to prevent further erosion. We weren't gonna reroute the.
Not like reroute it, like take it over to Greene County, somewhere else in Greene County, but move it over about 10 feet.
No,
Build
we
up the shore on this side and move it to the east a little bit.
We were just building up the shore so it wouldn't erode any further in. We weren't, my understanding of that project
Just
was
protecting it.
it would keep it in its pathway right now, but prevent it from eroding further west.
We definitely interpreted it differently. We have to revisit that maybe to clarify.
Based on your judgment, I know this would be hard to answer, but I thought I'd at least try. Do you see any land movement or the risk of land movement in other locations along the road beyond what we have currently?
I think it's a possibility.
Okay. That's fair
But
enough.
it's hard to say beyond that.
I understand. But you're saying the conditions are there for slippage to occur elsewhere?
Yeah.
Okay.
But at the same time, I don't know when the road was built, but it's been there for a little bit of time and there's not been too much, so if I could predict that, then I get asked that all the time. But
I
so
understand.
the conditions are there, whether it's gonna happen or not.
But if I'm reading your numbers right, I mean, we've got in excess of 13 feet of fill in some of those areas where you did the borings, and so that's where you're gonna have the movement, and
Actually,
when that road was put in place and how they compacted or didn't compact.
the fill is closer to 725, where it's probably less likely to slip. And you said that the slippage was actually where there was the least fill, is that correct?
It was where bedrock was shallowest.
Okay.
What's underneath the bedrock? You don't know?
More bedrock.
More bedrock?
Or
I mean, we usually stop at 100 feet at the most not for this, but just in general, but
In general?
it's more bedrock.
You keep going, you'll get molten lava.
The area you're talking about, the water's pretty deep there. It's kind of pooled up. You say that's where the bedrock's shallowest?
Yeah, where that Yeah, where the inclinometer is, but
Yeah.
it's, yeah, one of the areas of shallower bedrock, yeah.
Would the bottom of the creek be top of the bedrock pretty much?
No, it could come out above that.
Well, it's underneath that some.
It could, yeah. I mean, like I said, I didn't walk down there, but yeah, a lot of times the creek will go, I mean, it'll erode down into bedrock, and bedrock will be, the top of bedrock will be higher than
Okay.
the bottom of the creek.
The creek gets pretty deep back in there by the bridge.
That's what I was saying, that's where he's saying the bedrock shallowness.
Okay. Any more questions, discussion to council? Elaine? Okay. Mr. Gatorman, thank you so much. Appreciate your presentation. We'll probably be back in touch as we try to figure out ways to find the best way to deal with this situation, and we're probably a long way from done, so.
Right. All right, thank
Thanks
you.
a lot.
Thank you.
Thank you.
Do we have any further business to discuss during this work session? Can we have a motion to adjourn, please?
Motion.
Thank you. And a second?
Second.
Thank you.
Is that TJ?
Yes.
A motion was made by Dr. Van Veldhuizen to adjourn the work session of City Council, and this was seconded by Mr. Hope. All in favor?
Aye.
Aye.
We've got, my clock shows it's about 6:52.